امر موضوع كمان لسر ستريس ابيض اوكي دو جورا ستريس اخرانيين يكن في الان نورمال ستريس وابيديكا shear stress okay normal stress and shear stress in general stress here stress as mathematically you divide the force over the area so the force applied over the area so is the result of dividing the force over the area. This is what stress is about as a formula, okay? So, to show you the normal force. Okay. As an example, to determine a stress, the so-called normal stress in an axially loaded bar. In an axial loaded bar like this one, and we have an axial load, so the bar is axially loaded. We have this force P acting along this bar, okay, acting along this bar. If we want to determine the normal stress, when we say normal, يعني the stress that is perpendicular to the area the force is acting upon, and the force has to be perpendicular, normal to the surface, normal to the surface. That means the angle between the force and the surface that the force is acting upon is 90 degree. Okay, yani normal aware. This force, this is the surface, the cross section. The force acting perpendicularly, يعني أوها, if I show it to you, أوها, okay, the force is acting perpendicular and the angle is 90, normal to it, okay? So if you divide this force, if you call it P, then you, over this area, this cross-sectional area, okay, this area, okay, that would represent the normal stress. That would represent the normal stress. Yani normal stress, sigma usually is referred to as sigma. Sigma is equal to P over A. P over A, okay? And sigma sub n usually is referred to sigma or sigma sub n, okay? Normal force, sigma sub n, okay? So sigma or sigma without n or sigma with the sub n, okay, is equal to the force that is acting perpendicular to the surface over the cross-sectional area. Which area? The area the force is perpendicular to. The area the force is perpendicular. That is called normal stress, okay? Normal stress. So now we know what normal stress is about. انجا شتي كي ديك اخرين في الان shear stress او تاع sigma any تدانيا okay sigma in general sigma indicates that the stress is normal force over area. Which force? The force that is perpendicular to the area, okay, the force that is perpendicular or normal to the area, okay. انجا ينسر another type of stress, another type of stress او امر اخرين, another type called shear stress, okay, shear stress. So what this stress is about is again force over area, but what force we have to know what force, hold on. If you look at this beam, if you look at this part, okay, you can model it as a beam, okay, and you have a force like F acting upon this surface, okay, and you want to determine the if there is any shear force, if there is any shear stress, you would see that on the side, on the cross-sectional side, okay, so you have two cross-sectional sides. At each side, you have a force opposite to the force acting downward. So you have V and V. So that means these two V's, V and V, okay, opposite to F to have an equilibrium state for that part. to have an equilibrium state for that part. So if you want to calculate the shear stress that this force is acting on, the shear stress due to this force now is not axially loaded. If, for example, this F was acting this way, this is the force, this is the way the force is acting, whether it is causing tensile stress or compressive stress, it doesn't matter. As long as the force is acting normal to the surface, then we would have had this kind of normal stress, which is equal to F over A. Okay, F over A. Come on here. Okay, so what we have now is we have a normal force, okay, a normal force. If the force was acting on this surface, we would have a normal force, a stress acting upon this cross section, and the value is F over A. F is perpendicular, is normal to the surface, okay? Is normal to this surface. Or this force itself, and you get the area of this cross section, okay? So that you know how much of stress this force is causing to the surface, okay, as long as the surface is perpendicular. But if the surface is not perpendicular to the force, is parallel, okay, is parallel, as you see over here, the surface of this cross-sectional area is parallel on both sides. So that the stress that is caused by this force is not called as normal stress, is known as shear stress. The stress that is caused by this force along this surface is called shear stress. So we call it tau. Okay, we label it as tau. Tau means shear stress. Tau would be equal to the force over the area. Okay, so we can say that tau is equal to F over, if we label this side of the area, if this side is A as A, and the opposite side is also A, this side is also A, so we can say F over 2A, F over 2 times A, because we have two surfaces or two cross-sectional area on both sides. One side, each side has its own cross-sectional area, so we have A times 2, so that we represent two surfaces. So you can say F over 2 times A, this would be the shear stress, okay? This would be the shear stress, okay? So, أمرو أو دوش تأخرين shear stress or normal stress. Shear stress or normal stress, okay? So we go back to the normal stress. هوا هربو أو يبزانين چي بان بيستا بو أمبو, okay? What do we have to study يعني? So we go back to the normal stress and we see what kind of things we need to learn today. Okay. Normal stress. Now we study a bit about the units. Usually, stress is equal, whether it be it normal or shear stress is the same. Is force over area. Okay, force over area, which is equal. If it is the force is in Newton, then that would be Newton, and the area is in meter, for example, meter square. So you're going to get this kind of unit called Newton over meter square, and this unit is known as Pascal. Pascal, okay? Pascal. Newton over meter square is Pascal. But if you convert the area into millimeter square, so you're going to get like Newton over millimeter square. If you get this kind of unit, then this is you can use the same name Pascal, but it would become megapascal. Megapascal. Okay? If you convert a meter into millimeter, so you're gonna end up with, like, if you have Newton over meter square, okay? If Newton over meter square is Pascal, so how come Newton over millimeter square is megapascal? Because if you convert it, it would become like a Newton over millimeter square, okay? Okay, millimeter square, okay? Meter, if you convert it, times 10 to the power negative 6, right? To convert, to have this as megapascal, that means Newton millimeter square. You convert millimeter square into meter square, so you have to times it with 10 to the power negative 6. Okay, if you get this 10 to the power negative 6, okay, then you would get this 10 to the power 6 times Newton over millimeter square, okay, over millimeter square. So that means we have how many Pascal? We have 10 to the power 6 Newton per millimeter square. Sorry. Megapascal, 10 to 10 megapascal, mega Newton millimeter. Megapascal is Newton per meter square. Okay, so you have 10 to the 6, 10 to the 6 Pascal is Newton meter square. Newton meter square. Newton meter square. This is your unit. هني نخوارو about 10 Newton over 10 to the negative 6 times Pascal is Newton per meter square. So megapascal is supposed to be Newton millimeter square. Megapascal. 1 Pascal is Newton per meter square. Okay. Megapascal is supposed to be Newton per millimeter square, right? Newton per millimeter square. To convert this on either side, convert it to 10 to the power. Yeah, true. Let me check, true. So now we convert Newton over meter. If you convert meter into millimeter square, so you're gonna get millimeter square times 10 to the power 6, right? 10 to the power 6. And this would be Pascal, okay? So if both sides, you multiply both sides with 10 to the power 6, okay? Then this would eliminate this, and you're gonna have 10 to the power 6 on this side, okay? So you're gonna end up megapascal would be equal to this unit, Newton per millimeter square, okay? Have we got this unit? This is the most, you could say, widely used unit, Newton per millimeter square. Pascal is Newton per meter square. Pascal is Newton per meter square. Okay, Pascal is Newton. Sorry. Pascal is Newton per meter square. Okay, megapascal is Newton millimeter square. So how can we prove this? You convert meter square into millimeter. Each meter is 10 to the power 3 millimeter, right? So if you have meter square, it would become 10 to the power 6. Okay, so Newton over millimeter square times 10 to the power 6. Okay, to eliminate this power 10 to the power 6 from this side, you have to multiply both sides with 10 to the power 6. So you're going to end up with 10 to the power 6 on this side. okay, and this would be converted into millimeter square. So and 10 to the power 6 means mega, so we could say megapascal is equal to Newton per millimeter square. Okay, did you get the unit? Pascal is Newton meter square, and megapascal is Newton per millimeter square. Okay, so we jump into, so now we know we've defined what normal stress is about, what kind of unit we will deal with, and now we go, and this is the formula, which is simple. The stress is equal to force over area. Stress is equal, if we are talking about normal stress, the normal stress is equal to force over area, okay? So, example 1. A bar in the figure below has a constant width. This is the width of the bar and a thickness of 10 millimeter. Thickness is 10. جماعة باشني وساعات داخل كسناكم أو كتان الله من استوى باشني وساعات كس داخلناكم هم ساعات داخلناكم ده دقة مجال أيام لبداية باش أوا نية كس داخلناكم تا رستك okay وحسابها كم غياب بوي ساعات. So we have this example, Barak one here, okay. With the K is 35 millimeter, the thickness is 10 millimeter. Determine the maximum normal stress in the bar when it is subjected to the loading shock. If you look at this bar, this is the bar from A to D is the bar, okay. What kind of forces we have? We have two axial load on each side. One is 12 kilonewton, the other side is 22 kilonewton, okay? And in between, we have also forces acting along the bar axially, and these two forces also acting axially along the bar. So the question is asking us to determine the maximum average normal stress. The maximum average normal stress. So to solve such a question, we need to consider the bar from either A or D. So you started with either A, and then you take a section somewhere in between A and B. Whenever you see a change in force or sectional area, then you have to take a cross section prior to that. For example, so now we could see that we have a force acting 12 kilonewton, okay, 12 kilonewton along this side from A. So we have 12 kilonewton. And then if you go to B, is there any cross-sectional change? Any cross-section? Okay, no. So we don't need to worry about the cross-section. Up to the end, it seems that the cross-section is constant from A to D, so we don't need to think of the cross-section. So all what we need to think of is if there is any force that would change the amount of stress. So do we have from A to B any force in between A and B, force here? There is no force. But at B, we have 9 to, that means 18 kilonewton acting toward the 12. So prior to that, in between A and B, you can take a cross section. So we have one section, okay? We have one section, okay? It could be anywhere. You take it close to A, or you take it close to B, or you take it in between, anywhere in between. It could be mid-span, anywhere. You could take it in between, okay? This is one section that you can make use of to determine the stress, okay? Then you go further from B to C, okay, after the force has been included, okay, force is included because we have taken this section. Now the force from B to C, the force is included, and then you have to take a new section from B to C. If there is any change of force, you don't have any change of force except that these two forces are included, all the way to C. No forces, no new forces introduced to this element, except at C. At C, you have like two forces introduced to introduced to the bar at C. So you could take a section anywhere from B to C. Okay, another section, we call it section 2. You label it as section 2. Okay, section Iduhan. The same thing, you go from C after, of course, after taking 4 into account. So that means from C to D, we have to see if there is any force. Any force? Do we have any force? If you include 4, any force? No force. Up to D. Up to D, you have this 22 kilonewton. So you could take a section anywhere in between C, anywhere in between C, could be close to D, could be close to C, could be halfway. It doesn't matter as long as you take a force, a section, and you label it as section 3. Okay? Now we will understand why. So now we have 3 sections. 1, 2, 3. Okay? باش. زين حلكي. Okay, هنا كي. لا بين. Okay. For section 1, أجابينا سارة. Sorry. For section 1, which could be here, okay, we have 12 kilonewton, 12 kilonewton, and making use of the equilibrium equation, we can get the force acting axially along the member, which is opposite and equal to the 12 kilonewton. So we can get, you label it as force AB. That means the force acting along AB. The force acting along AB could be found this way. Okay, so summation of forces, and LA, after you get that, this is the cross section. This is the cross section 1. Okay, cross section 1. Okay, sorry, 1. You say the summation. You don't know about PAB, so you just say PAB. You don't know how much is it. Say summation of forces, Fx is equal to 0. So you get 12. Okay, and then you definitely know the direction. You don't need to have a wrong assumption for the direction, because PAB definitely is opposite to the 12. So you say negative PAB, okay, okay, is equated to 0, PAB. Okay, so surely PAB is equal to 12 kilonewton. So you've got PAB value, okay, for section A. Okay, so now we have calculated PAB this way. The same way we calculate all the rest forces, PBC and PCD, okay? You calculate it the same way. So how many sections he has taken? The same thing. 1, 2, 3. Only 3 sections to solve the problem. We needed 3 sections. For the second section, after the 9 forces included, so the summation of forces along the x-axis would be equal to 0 to determine this PBC, okay? This PBC to determine it. So now we also can know the direction of PBC, because these 2 9 opposite, in the same direction with 12. So you could say you have 18 plus 12, which is equal to 18 plus 12 is equal to 30, acting this way. So definitely the force acting on this side would be opposite and equal to 30 kilonewton. So you have to apply this equation. Summation of forces along the x, okay, is equal to 0, and then you're going to get PBC. The same thing you apply to this section, the last section. You don't know the force that is acting on PCD. You don't know it. You just know that you have a force on this side. If the section, you have 2 choices. You can solve it this way or the other way. It seems that he has taken the right side of the section, not the left side. So you have the other choice. Hold on. You have the other choice. For example, if you take the left side of the section this way, okay, you can solve it this way too. So you say this is section 1, 2, 3, okay, and then all the forces these on this side, you have to calculate all the forces, and then based on that you can get how much of force you're going to have on this side, how much of tensile force you're going to have on this. So you apply the same equation, summation of forces along the x-axis, summation of forces along the x-axis equated to 0. Okay, so you take this section and you call this what do you call the force acting along AC. Okay, you could say P from A to C or C to A. Okay, but why did he take the right side? Bochi Lepusiaraka, he didn't take the left side. Who knows why he chose the right side rather than the left side of the section to solve it here? Why did he choose the right side rather than the left side? Rabbi. Hello? Rabbi.
Hello, Ustaz.
Why did he choose, in the question, why did he, in the answer, why did he choose the left side of the section, sorry, the right side of the section, and he didn't take the left side? Bochi section kawarigar, Hamo section akan, he took the left side. Ama left, amash left, Geshta am section, yani babina sarawa, ama. Am section, he took the left, am section, she took the left to get the force, internal force. Well, am section, he took the right side. He didn't take the left, the Pusarka, which is the same. He could have taken the left, and he could have ended up with the same result. But why he decided on the right side? He took the right side.
Because biz dedik kilonewton bara right side Ustaz.
Exactly, because it's easier for him to know the internal force by looking at the right side. You don't need to calculate. He doesn't need to calculate all these forces to get how much of force acting along across this section. So if you look at this side, you just have 22, then you have an opposite force which has to have the same value 22 but opposite to it. Okay, so that's the answer. He took the left side, he took the right side because it's easier to solve. Okay, why would it be important? Because you save time in the exam. You can save time by taking the easiest side of the cross section. Once you decide on the easiest side, you will save time. You don't need to have many calculations. You don't need to consume time for calculations, for excessive calculations. Okay. Okay, so now after we've got the forces, now we calculate the stresses. Now 12, the stress over this part. You look at the maximum force. Which one is the maximum? 12 or 30 or 22? Which one is the maximum?
30 kilonewton.
30. So based on that, we calculate. Okay, now the stress at BC would be the maximum normal stress for the applied loadings. So we know that BC or P sub BC is equal to 30 kilonewton. So we have force over area. Force is 30, convert kilonewton into newton, so that makes it 30 times 1,000. We've converted kilonewton into newton, so we have 30,000 over the area in millimeter. So we have newton millimeter square. So we will end up with newton millimeter square. Newton millimeter square. Okay, newton millimeter square. So once you get the result, surely you have 85.7 to the power you have newton millimeter square. So if you divide this over this, you're gonna get this much to the power. Maybe any power? No, there would be no power. So it's supposed to be 85.7 megapascal. Okay, megapascal is Newton, as we mentioned, Newton per millimeter square. Okay. Megapascal is Newton per millimeter square. Okay. So either you write it Newton millimeter square or you say megapascal. The same thing for Newton meter square. You either say Newton per meter square or you say Pascal, okay? But usually we refer to it as megapascal or Pascal, okay? For the stress. Bash. Second example,
الأستاذ
بله
لم ساري تازا سي انترنال فورس مانديتا
بله
بو حساب شير ستريس كاما قولتينا ماكسيميم أو حساب دكين أو هيزا وردقري
حساب كردني چی وتت؟
شير ستريس أكا
شیر سترس نیه اما نورمال سترس لێرە شیر سترسی تێدان نورمال
ستريس أكا
بله
ماكسيميم أكا حساب أكاين
خۆی لێرە داوای چی کردووە determine the maximum normal stress in the bar okay فأو لە جیاتی حسێبی ئەمە بکات 12 لەسەر ئەو cross sectionە C لەسەر ئەو cross sectionە هەموو یەک cross sectionی هەیە بە تۆ دەزانی ئەگەر سەرەوە گەورەتر یعنی گەورەکەیان لەسەرەوە ئەو maximum stresست پێ ئەدا وانە پێویست ناکە ئەمە دابش cross sectionی بکەی ئەوەش دابش cross section ئەوەش دابش cross section دوای سێر بکەی بزانم کامنی maximum بڵێ ئەوەیە وانە so immediately you can determine the maximum by knowing that you have 30 kilonewton or 30,000 newton over the same cross section for all the forces. So which one is the largest? 12 or 30 or 22? Which one is the largest? 30. So definitely this force would result into the maximum normal stress. Atwani, yahar yakeu stressi khoi count bukay. Datwani. You calculate for this, and you calculate for this, and you calculate for that, and then you say, this is the largest one. This is the largest one. This would result into the largest normal stress in the member at this section. تيجي يعني دتوانية calculate همو stress كان بكي وبلاي أما جورا كأنا بس تو basically formula كي ديارة